how do we measure an exact physical distance in a mathematical system built on imaginary numbers? The modulus represents a measurable line stretching from the origin to a point in space. To find the modulus of z equals 3 minus 4i, we choose between four options: 25, -5, 5, or the square root of 7. To reach the correct result, we must translate this algebraic equation into pure geometry. Look closely at that diagonal distance line on our grid. When we drop a vertical dashed line straight down to the horizontal real axis, we form a right triangle. The base is our real number, a, and the height is our imaginary component, b. Because this forms a right triangle, the ancient Pythagorean theorem maps onto our modern graph. By taking a squared plus b squared equals c squared and isolating the hypotenuse, we define the modulus. The absolute value of z equals the square root of a squared plus b squared. Finding the modulus is simply finding the longest side of a right triangle, hidden in plain sight. For our value z equals 3 minus 4i, our real part a is 3, and our imaginary part b is -4. Crucially, the imaginary unit I only indicates direction on the vertical axis. It is excluded from the b value used in our calculation. Take a moment to plug those extracted values into the formula yourself. Squaring 3 and -4 gives us 9 and +16. Combined, they simplify to the square root of 25. Following these steps yields an unambiguous result of 5. Now we can compare the multiple choice options against our calculated result. Option A occurs if the squares are completed but the final square root is forgotten. Option B is -5. Because the modulus measures a physical distance on a plane, a negative result is logically impossible. With the final outlier of root 7 dismissed, we can confirm option C as the correct solution. Mapping complex algebra to simple geometry clarifies the process. Just extract your values, drop the I, calculate the hypotenuse, and remember that physical distance is always positive.